From Weatherford, one of the world's largest and fastest growing providers of surface logging systems, comes a game-changing innovation in surface gas detection and evaluation. GCTracer. Now, for the first time ever, you can extract formation gases and analyze them accurately and reliably from the surface, in real time, regardless of mud type, flow rate, gas solubility, or temperature in the flow line. Never before has it been so easy to evaluate formations and track all facets of the progress of your well. In mud logging, gas data and rock cuttings are generated downhole. The gas and rock cuttings are transported by the drilling fluid to surface. Here, they are analyzed to create lithology and gas logs that are both time and depth-based. The mud logging unit is the nerve center for all drilling and geological operations. LWD, MWD, and wireline data can be streamed into the unit and integrated with the mud logging data in real time. Traditionally, gas has been extracted from drilling fluids using an agitator trap. The trap is usually located in the header box of the shale shaker. A rotating blade agitation system beats the mud into the bubble phase. The gas is then pumped out of the trap and through a polyflow line to a gas detector, which is housed inside the mud logging unit. The problem with the traditional gas trap method is that it is inefficient and its measurements are inconsistent. Gas is retained in the mud from 1 to 15 minutes. During that time, mud type, flow rate, gas solubility and other variables can affect the samples and skew measurements of gas concentrations. The average time that drilling fluids are exposed to the trap is less than 2 minutes. Yet even after 15 minutes, a significant amount of gas is still left in the mud, and the heavier the gas, the more that is left. So the measurements are not accurate enough for quantitative analysis, and they often lead to costly qualitative misinterpretation. GCTracer changes all of that. Using a high-speed gas chromatograph and a patented membrane-based probe, the GCTracer can accurately identify, quantify, and analyze hydrocarbon components in any drilling fluid. This makes it the most flexible and accurate gas measurement technique available at the well site. With GCTracer, you can pick casing points, formation tops, and pay zones with remarkable precision. The heart of the GCTracer is a patented probe with a semi-permeable membrane that can be inserted directly into the drilling fluid. As formation gases flow across the membrane, they are extracted as a result of the difference in partial pressure between the gas in the drilling fluid and behind the membrane. This difference in pressure allows each gas component, whether free or dissolved, to permeate across the membrane. In this way, both hydrocarbons and non-hydrocarbons are extracted. A carrier gas continuously sweeps the membrane to maintain the pressure differential and transport the gas samples through the sample lines to the GCTracer's rugged explosion-proof enclosure. Inside the enclosure, the system's high-speed gas chromatograph enables fast and precise analysis of the samples. Hydrocarbon gases from methane to octane can be analyzed in less than 1 minute. So can non-hydrocarbon gases such as nitrogen and carbon dioxide. When run in express mode, methane to pentane can be measured in just 20 seconds. Compare that with other systems which can take up to 5 minutes to sample the same range. The GCTracer's speed dramatically increases the resolution of data capture and reduces the risk of missing bypass pay and weakly defined zones. With GCTracer, you can also analyze aromatics such as benzene, toluene. You can customize your acquisition program to meet your needs. All in all, you can now have a much better understanding of your reservoir, and you can identify and estimate lithological changes. Net pay, fluid density and rock permeability, all from measurements taken at surface. With multiple installation options, the GCTracer is as flexible as it is efficient and accurate. For example, it can be deployed in a delta configuration. This means you can use it to measure both gas coming into the well and gas going out. The in-gas measurement is typically installed in the suction pit, while the out measurement is installed in either the header box of the shale shaker or the flow line. Flow line placement ensures gas detection regardless of what operation is taking place at surface, such as bypassing the shakers or diverting through a gas buster. The GCTracer can also be installed directly into the flow in closed systems, such as managed pressure and underbalanced drilling. For these systems, Weatherford has developed a custom-engineered bypass valve, which makes it possible to perform maintenance work on the probe without interrupting drilling operations. GCTracer can help you geo-steer and can indicate at which depths to take wireline fluid sample points. Its measurements can also be used in post-well analysis along with other parameters to reduce reservoir uncertainty. The design and functionality of the GCTracer are impressive, but the results are truly amazing. Just look at this comparison sample table. Gas compositions from GCTracer can be related directly to actual reservoir compositions. No matter what type of drilling scenario you encounter, onshore, deep water, HPHT, shales, even heavy oil, you can count on superior gas measurements, more accurate formation evaluation, and reduced reservoir uncertainty with GCTracer. And you can count on Weatherford for technology, professionalism, and exceptional customer service that positively impact all your drilling economics. Contact us today.